All right, so here's 2012 APA Calculus free response question number 2 in your Volumes of Solids of Revolution notes. I will go over A, B, and C. You asked about C specifically. C is difficult, okay? This is very difficult, I would say. So yes, this will challenge your thinking. Let's first of all start with A. Of course, what we have to do to find the area of R, and I don't know if I need to zoom in a bit with this. You guys see that all right? So to find the area of R, okay, I need to find an integral or two integrals that will give me the area underneath the two curves. So what we're going to need to do is we're going to need to find this intersection point, okay? And if you use Desmos or graphing technology, I think you should find that intersection point as being, tell me if this is close to what you got.
Yeah.
Okay. So 3.693 and then comma 1.306, that kind of thing, okay? So that's the intersection point there. The x value here is pretty important. It's what we're looking for. We see that it starts at 1, and if this is to be trusted, it appears that it ends at 5 here, right? We can easily test that. This line right here is the 5 minus x. So if y is to be 0, then x would need to be 5, right? So this is the x-intercept of 5. So we've got 1 to this value of 3.693, and then we've got a 5 there. Okay, so to find the area, we'll need to find two separate integrals, one for this and one for this. So that should look something like this. For A, you should have the area is the integral from 1 to, and I will call this A, okay? So 1 to A, this, so I don't have to write out that whole decimal. 1 to A, and that's going to be ln of x, right? Ln of x, and then really minus 0 because that's the lower function, so it's just ln of x dx. Okay, plus we're going to have the integral from now this lower limit is a to the upper limit of 5, and that's going to be of this function 5 minus x minus the lower function, which would be 0, or the x-axis, dx. And so our area there, without much ado, again, you can use your technology. This is easy to integrate by hand as well and evaluate. Should be about 2.986. Okay? So did you get that for an answer for A? We're all on the same page for A. Any questions about that? Okay. All right. So that's not too bad. Now, what does B say? Region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Okay, so this is square cross-sections, right? No problem. They protrude out from the x-axis and they're perpendicular. Tough to draw that way, but you can see as the distance from the function to the x-axis grows, so does the size of the square. Okay, square. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. Okay, so for B, what we will take a look at then is the volume of this. Again, there's no pi r squared. We're not revolving. We're just doing cross sections. And the radius, of course, is the function value, right? The f of x minus 0. So we're looking at the integral from 1 to a. We still have to split this up into pieces, right? So the upper function here is the ln x. So ln x minus 0, of course, and that's going to be squared there, plus the other integral from a to 5 of 5 minus x minus 0, and that's going to be squared. So you do have to evaluate that. The only difference between a and b is this squared, right? Multiplying the side length here by itself, so we're squaring it. You do not have to solve it. And again, if the question, you have to read the question carefully. If it says write an integral but do not solve, just stop at the integral. Okay, don't do anything extra or anything less than what they ask. Just give them what they ask for. So we're good with A and B so far? Okay, I'll zoom out a bit so we can have a little bit more in view. I don't want to make that too small for you. Okay, so C is the tricky part here. I will fully grant that C is off the wall here. It's kind of tricky. So let's see if we can figure this out. And if you tried this, and if you haven't tried this yet, and you're watching this video, I would suggest you pause right now. Try C. Just see how far you can get, and then we'll go over it in a bit here. All right, so we have a horizontal line y equals k, okay, a horizontal line, that divides R into two regions of equal area. Now, we don't know where K is situated. Is K, going to be down here somewhere? Does this bottom half look like the same area as the top half? Probably not. Is K going to be way up here? No, that little top half is definitely not equal to the bottom half there, so it's not up there. K is going to be somewhere around here, okay? That's going to divide the region into two. Now, we don't know what K is. We're going to have to solve for K, so we have to set up some kind of integral situation where we can solve for K. So the top half and the bottom half, okay, need to be equal, and they both need to be equal to half of the area that we have determined in A, okay? So whatever we set up here has to be equal to, if we set up an integral for 1/2, okay, which would probably be the easiest one to do, that's going to end up to be half of 2.986, okay? So let's go back over here now. So again, we're looking for area, but in order to solve for K, okay, K is the Y value, right? K is going to be the Y value for both the ln x and the Y value for the 5 minus x function. So here's where it gets a little bit funny. So K that we're looking for is going to be equal to ln x over here. Okay, so K, this is the value of ln x over here. And K is also going to be equal to the value at the same time of 5 minus x. So, right, it's got to be the same K. So it's the same Y value. So this K has to be equal in both cases because it's got to run through both functions. Now, in order to find the x value that is associated with each of these, that's kind of the key, right? Oh, it says right, but do not solve. Oh, okay, fine. An equation involving one or more integrals whose solution gives the value of K. So we are trying to solve for K. K is going to be our unknown. So right now, if I write my integrals in terms of ln x and 5 minus, that's in terms of x. I do not want them in terms of x. I will need to solve for K. So I need to solve for x here. Okay, I'm going to need to solve for x. So I'm going to rearrange these equations. This is going to be e to the k equals x. All right, and this one is going to be 5 minus k. We're going to put x on the other side. We're going to subtract. So x equals 5 minus k. Okay. So now I have the x's now in terms of k. Okay, the x is now in terms of k, and I'm going to try and see what I can do there. So, okay. So if I take a look at this this half right here, let's see if I can explain this here. So this half right here, I need to focus on, I guess, this being exactly half of this full area. So those two parts are going to be equal. So well, actually they don't have to be equal, but what I need to do is to try and split this up into, what's happening? The computer's jumping around on me. I need to try and focus on, the x value, right, that will cause this top half plus, when I shift over here, this other top half, that is going to equal half of the total area. So I'm going to focus on where is x to a here, right? Where does x start? Does x start over here, therefore making this the line? Is x over here making this the line? Or is x back over here making this the line? Or is x, right here making this what looks to be the line? So it's going to look like this. The integral, I'm going to have to back up. The integral from this value of x, which is e to the k, to a. So e to the k to a, and that's going to be an integral involving ln of x, the upper function, minus the lower function now, which is k. I need to find out where that lower function, I'm solving for k here. Dx, okay, plus the top half, or the half of the other section, which goes from a to 5 minus k. Now notice here that this x value, so we have a to this x value, which this x value is 5 minus k. So from a to 5 minus k, and that is going to be the upper function, which is 5 minus x minus k dx. Yeah, and that's going to have to equal, so this, basically half of this, or this integral, which represents half of this area here, either this area or this area, it actually represents the top area because it's going from the x to the a, right? So it's the top area. Where this is the upper function on top, ln x, and k is the lower function. So we're trying to identify this, we're setting this area, plus 5 minus x is the upper function, and then k is the lower function. So this area here, when we add those two up, that has to equal half of the total area that we've already determined. So this is equal to, where did it go? Half of 2.986. Okay, so we do have x's in here because we are differentiating with respect to x. So we do have x's in the integrals, but the x values, and this is the tricky part, that the x values have to be written in terms of k there, because we have k moving. So this moves as this moves. This k here, right, has to shift as this shifts. So they both have to shift together. If this was locked in place as x, then the k here wouldn't be able to move. You know, the k line wouldn't be able to move because it's associated with the values of the function as well. Again, that's the best I can do here, but that's your integral. That's your integral. This has to move as this moves. So you need a k in your limits of integration and as part of your unknown lower function there. So again, we're trying to set up this blue half plus this black half to equal exactly half of the total area. That will yield us a k value. Okay, the k will then be inherent there. That k value will then be the horizontal line that divides it exactly in half. So I'll zoom out a little bit there so you can kind of see the whole thing. But yeah, that would be right up there, high difficulty. And I think the biggest thing is these limits of integration actually. That's what I think trips up students most, is why is this e to the k? Why isn't this ln x? Right? Why isn't this just ln x? Well, ln x is a y value, first of all. E to the k is actually an x value. Ln y is a y value, I should say. And then the x value is x or e to the k. So as k is able to move just as the line is able to move, then they match together. Okay? Any questions about that?